Hi grade 11s, welcome back to another one of our video lessons. So today we're going to continue with unit 3, which is volume. So remember in our previous two lessons we did perimeter, surface area and area. Now we're going to extend that to work out volume and work out how much water or liquid or air fits into a particular shape. Alright, so before we start, let's first talk about how do we convert from normal units to cubed units. Because remember, a square unit has two dimensions, and we said it was, well, our example in the previous lesson was 1 centimeter by 1 centimeter, which was 10 millimeters, right? So that gave us surface area. Now volume is now three-dimensional. It's got length, width, and height. So we have to now make a cube that is 1 centimeter in length, width, and height. So this is also 1 centimeter, and that's also 10 millimeters. Okay, so I'm just going to draw this cube. All right, so imagine a little block in front of you, or actually a small block because it's 1 centimeter. So maybe a die that you use to play Monopoly or something like that. So if it's 1 centimeter by 1 by 1, it looks something like that. All right, so again, we're going from the simple conversion of 1 centimeter equals 10 millimeters. Okay. I just want to find my pen. That's not writing. 1 second. Here we go. Okay. So 1 centimeter equals 10 millimeters. Then remember in the previous lesson, we said 1 centimeter squared was 10. Well, it was 1 centimeter times 1 centimeter, which was 10 millimeters times 10 millimeters. So it was 10 millimeters times 10 millimeters, which gave us 100 millimeters squared. Okay. Well, we're going to extend that one step further for volume. So we're going to say, well, 1 centimeter cubed is 1 centimeter times 1 centimeter times 1 centimeter, which is what we have here. So that will give us 10 millimeters times 10 millimeters times 10 millimeters. Okay. 10 times 10 times 10 will give me 1,000 millimeters squared. Okay. So, guys, the idea is exactly the same. Start with the basic conversion. Draw yourself a picture if you don't know how to think about square units or cube units. Think of a square block, a cube block, a die that you roll. All right, guys, so that's how we would convert. So that's step one. Now, with volume, think about volume. We usually talk about liquids in volume. And liquids, we do not measure in cube centimeters. Yes, we can, but when we come to a shop and we pick up a carton of milk, it won't say, 500 cubed centimeters. It will say half a liter or a liter. So we need to know what is the conversion from cubed metric units that we use to measure distances and area and volume to liters that we use to measure liquids. Okay, so the basic idea or the basic starting point that we're going to use is 1 liter. Okay, 1 liter roughly takes up an area or volume of a 10 centimeter by 10 centimeter block. Okay, so if we have our cube like this is 10 centimeters, 10 centimeters, and so width is also 10 centimeters. So imagine we have a cube 10 by 10 by 10. It's a small little square like this. It's not even that big, or a cube rather. And what we're going to do is we're going to fill it up with milk or liquid or whatever, and that will give us exactly 1 liter. Okay, so what is this that we have here? Well, 10 centimeters times 10 times 10 is 1,000 centimeters cubed, right? That's the volume of this block, 10 times 10 times 10. Well, that is also 1 liter, right? Because that's what we are told. And also remember, 1 liter equals to 1,000 milliliters. Okay. So 1,000 centimeters cubed equals 1,000 milliliters. So therefore we can make the conclusion that 1 centimeter cubed equals to 1 milliliter. Okay, guys, that's what you're going to use to convert from volume to metric units. Okay, so if I say, if I have a cube that measures 20 by 20 by 20 centimeters. How many liters of water is it going to hold? Okay, so you're going to work out your answer in centimeters cubed, and then you're going to convert it into milliliters. Or you're going to work out 1,000 centimeters cubed is 1 liter, and then we're going to do the conversion. Okay, guys, so I'll show you an example of what I mean when we do that. Now what we need to do is we need to work out the areas or the area formulas for the different shapes that we have, okay? And primarily we're going to be dealing with our rectangular prisms, our cubes, and our cylinders. Okay, so let's work out the volume for a rectangular cube. So our volume is going to be, well, it's the same as the drawing that I drew before. Here's our cube. It has length, it has width, and it has height. Okay, so volume is length times width times height. Literally 3 measurements, that's where the cubed units come from, because it's millimeters times millimeters times millimeters. Okay, right, now we can have the volume of a cylinder that looks like that. So I touched on that last lesson. So here's our cylinder. Remember, circles, you need a radius, and this is our height. Okay, the arrow indicates the height of the cylinder. Okay, so the volume of that cylinder is going to be the area of the circle times the height of the cylinder. So it is pi r squared multiplied by height. Okay, and again, the units are going to be cubed because we got radius squared times another dimension, that will be cubed units. All right, guys, that's pretty much the formulas that we're going to need to work things out. So let's look at worked example, and it's a worked example on page 169. So it says, look at this cube-shaped tank in the diagram on the right. What will the height of the water in the tank be if there are 500 kiloliters in the tank? All right, so look at the cube-shaped tank in the diagram on the right. So look at the tank over there. We have 500 kiloliters in the tank, and we are missing one of the dimensions. Okay, so do you see how they're asking the question backwards here? So they're not saying, here's the dimensions of our tank, how much water is fitting into our tank. They're saying, here's two of the dimensions out of the 3 that we need. There's 500 kiloliters in the tank. What is that other missing dimension? Okay, so all we have to do is we just have to write out the correct formula and solve for the unknown that we have. Okay, so let's do that. So they say they have a cube shaped. Guys, the wording is here very important. If I say it's a square, it means the sides are the same. If I say it's a cube, it means all the sides are the same as well. Okay. So they say that there's a tank that holds 500 kiloliters. Okay, so we're using our volume formula. So the volume is length times width times height. They're telling us that the volume is 500 kiloliters. Okay, right, so that's that, which equals to, well, the length of the tank. What do they tell us in the diagram? It's 10.76 meters. 10.76 meters. The width is also 10.76 meters because it's a cube, so the two sides are equal. And the height is unknown. The height is what we are trying to solve for. Okay. Sorry. Okay, so that is our formula. So the trick here is to take the information, fit it to the formula, and then see what it is that they want us to solve. Well, we need to find the height, which means we need to get rid of all the stuff in the front. So what I'm going to do is I'm going to divide by these two, this 10.76 squared, because there's 2 of them. So that will cancel with that, leaving me with the h. And what I do to the right, I must do to the left. So divide by 10.76 squared. Right? That cancels with that, leaving us with the height. And the height will equal to 500 over 10.76 squared. Okay. And that's what they have. And that is approximately 4.32 meters. Okay. What units is that? It's just meters. Why? Because it is a length. It's not the volume of the tank. They told us that the volume was 500. So the length of that is just, well, the dimensions is just 1 meters, not squared, not cubed. Okay. All right, guys, so that is the worked example. So what I want you to do is look at exercise 8. Okay. So exercise 8 looks at exactly the same thing. So volume of a cube that has sides of 7.5 centimeters. Number 2, what is the volume of the rectangular prism? And so on. All right. Let's look at number 3. So I'll help you with that one. So it's now the conversion from liters to milliliters. So number 3 says a 1 liter milk carton has a volume 1000 centimeters cubed. How many milk cartons would you need to make up a volume of 1 meter cubed? All right, so they say that imagine we have a 1 liter milk carton that we buy in the shop. They say how many of these 1 liter milk cartons will fit into 1 meter squared, okay? Well, we need to do the correct conversion to work that out. So 1 meter squared is how much? Actually, not squared, cubed. Right? Well, what units are we converting to? They told us 1 liter of milk carton has a volume of 1000 centimeters cubed. So it makes sense that we convert this to centimeters cubed and we divide that by each carton, which is 1000 centimeters cubed, and then that will tell us how many cartons we have. So I want to convert this to centimeters cubed. Okay, how do we do that? Well, remember, 1 meter cubed is 1 meter times 1 meter times 1 meter. Okay, but we also know that 1 meter has 100 centimeters. So 100 centimeters times 100 centimeters times 100 centimeters equals 1. How many zeros? 6 zeros. 1, 2, 3. 1, 2, 3. What? Centimeters cubed. All right, so 1 meter cubed is actually 1,000,000 centimeters cubed. So how many milk cartons do we need? Well, the number of milk cartons equals the total, so it is 1,000,000 centimeters cubed divided by how many milliliters cubed in 1 milk carton? It is 1000. So we're going to divide by 1000, cross the 3 zeros out, top and bottom, and we get the answer of 1000 milk cartons. Okay. Guys, that was a basic example in terms of liter conversion. I mean, a better example would be in the next exercise or the next 2 exercises that you're going to do, where they give you a house and they say, right, well, if we want to paint the house, what is the surface area? If we want to fumigate the house, what is the volume of gas that we need to pump into this house if it has these dimensions? So all of these questions that are going to come on these 3 sections are going to be application questions. We're not going to say, here's a cube, work it out. We'll say, here's a house, okay? Work out how much each room is, add it up, and show me how it all works. Okay. All right, guys, so exercise 8, I want you to complete. Then at the bottom of page 169, they go through the formulas that I did on the board for the rectangular prism and the cylinder. So have a look at those if you get confused. And we can look at the next page, 170. So exercise 9 and 10 is what you guys have to do for homework. I'm going to work through the 2 worked examples to give you an idea of what's coming ahead. And you guys are going to do the rest. And after you've done the homework, I want you to please do the revision section at the end of this chapter. That will revise everything together and we can move on. Okay. So let's look at the worked example on page 170. So it says calculate the volume of a cylinder on a base with a radius of 3 centimeters and a height of 5 centimeters. All right, so they say there's a cylinder with a base of 3 centimeters radius. So this is 3 centimeters. And the height of the cylinder is 5 centimeters. Okay. So we need to find the volume of the cylinder. Remember, the volume formula is it's the surface area of the circle times the height of the prism, or rather the cylinder. So what is it? It is pi r squared multiplied by the height. Now, guys, when you are answering these questions in the exams and tests, there's a mark allocated for using the correct formula. So please don't enter this onto your calculator and then just give me the answer, or put in values and give me the answer. Your step number one is to tell me which formula are you using. That's 1 mark. Okay. Your step number two, you're substituting values in. So this is pi. Radius of the circle is 3 centimeters. Put it into brackets, squared. Multiplied by height, which is 5 centimeters. Okay, and that will give us an answer of 3 times 3 is 9. 9 times 5 is 45. So this will be 45 pi. And what units is this? It's centimeters cubed. Okay, you can, depends what the answer says, but obviously put this into your calculator and give me a rounded off answers to say 2 decimal points. Okay, well, let's see what they say. They give it to us to 1 decimal point, and it is 141.4. 141.4 centimeters cubed. Okay. If you notice, guys, also, here's another important bit, right? So let's say the question says, work it out and round it off to 1 decimal place. Okay, so firstly, there's a mark for the formula. There's probably a mark for substituting your values in. Now, once you write your answer, there's a mark for the correct answer, and then there's a mark for rounding your answer. And notice in the textbook, they use these squiggly equal signs, which means that the answer has been rounded off. So if it's a question like this, there's about 4 marks here. 1 mark, 2 mark, 3 mark for the correct answer, 4 marks for actually rounding off the answer. Okay. Cool, guys. So that's worked example number 1. Let's look at worked example number 2. A 5 kiloliter cylindrical tank has height of 2 meters. What is its diameter? Okay. So again, they give us a volume application, so therefore we need to use our volume formula. So the idea here is that we're going to substitute our values into the formula and see what is the unknown that we need to solve for. Okay, so let's continue with worked example 2. So it says a 5 kiloliter cylindrical water tank has a height of 2 meters. What is its diameter? Okay, so the trick here is that we are used to working with radius. They're asking for diameter, so there's an extra mark for that conversion right at the end. Okay, so let's try to figure out what they want. They say there's a tank. There it is, and it holds 5 kiloliters. Okay, kiloliters, 1 kiloliter is 1,000 liters, but it doesn't really matter what kiloliters we're working with, since we're working with meters for radius and height. So that's what we're really after. So 5 kiloliters. So if we use our volume formula, it equals to pi r squared times height. Okay. Sorry guys, my Coke is running out. Let's try another one. Okay, so volume equals 2 pi r squared times height. Okay, what we're going to do is we're going to fill in the unknowns here. So our volume is 5 kiloliters, they told us. Pi is pi. The radius, they asked us for the diameter. So obviously to get the diameter, we need to get the radius. So the radius is what we are after. So this is r squared multiplied by the height of the tank. They tell us it is 2 meters there, so it's times 2. So here we are after the radius, guys, but the radius is squared, which means that we now need to square root both sides to get rid of that square. So remember how we divided by the coefficient of the variable to get rid of it? Now we need to get rid of the square, so we're going to square root both sides. Okay, so what I want to do first is isolate this r squared. So I want to divide by this 2 pi over here on both sides. So I'm going to do that, divide by 2 pi. It will cancel with that and that and that. Whatever I do on the right, I do on the left. So I divide that by 2 pi. So what I get is, and also I like to flip things around because your variable needs to appear on the left. And remember, equality means equal, so the two sides are exactly the same. So this leaves me with r squared. So my r squared equals to 5 over 2 pi. Okay, we're getting there. Now we need to get rid of the square. So we have to square root both sides. Remember, what we do to the left, we do to the right. We square root that, we square root that. This square cancels with the exponent square, which leaves me just the r, which is what we're after. And that equals to root of 5 over 2 pi. Now then, when you put this onto your calculator, you'll approximately get the answer that they get, which is 1.8 meters. Okay. All right. Guys, so these questions are a little bit trickier because they want you to understand the formula and understand that there's a few components here. There's volume, radius, and height. So in order to make this formula work, there's 3 pieces of information. I can give you any 2 of those and ask you for the other one. I can say, if I have radius and height like this, what is my volume? Or I can say, my volume is this, my height is that, what is my radius? Or my radius is this, my volume is that, what must the height of the tank be, and so forth. Okay, guys. So to practice, I want you to do exercise 9 and exercise 10 for homework, and also do the revision section. So the revision is obviously going to be for the end of this week, for the following week, Monday. So this is the work that we've covered for this week. All right. Guys, I hope you enjoyed it and understood. Please stay safe, and I'll see you guys soon. Ciao.